disjoint sets. Okay, these are just very few topics about sets. Okay, so again, we'll be talking class about subsets, equal sets, and disjoint sets. So by the way, do you now have an idea of what are these sets all about? What are subsets, equal set, and disjoint sets? As we have a background about subsets, equal sets, and disjoint sets. Okay, so well, I guess if there's none, well, we'll go through all of these sets in this lesson. So you should be able to differentiate a subset, equal, and disjoint sets. But I guess the word itself will speak what do these sets are. Like equal sets, we could somehow infer that equal, the two sets are equal, they contain the same elements. Okay, then we'll be talking class. You should be able to identify whether a set given is a subset, equal set, or that is a disjoint set. Okay. Now I want you to take a look class on this illustration or in this image. How many groups do we have in this picture?
3.
We have 1,
3, sir.
okay. Now from the given illustration class, okay, so we have 3. 3. Are there only 3?
Yes, sir.
Sir. Yes, sir.
Who says class that there are 4?
Ako.
Who says class that there are 4?
Forma, aserte nga.
Okay, so we have the set of this one. Okay, this one classes are the sets of plants, right? Then
Yes,
these
sir.
are the sets of human beings, sets of animals, and then we also have class the set of all living things. So how many sets do we have?
4.
4.
Okay, yeah, so the largest set we have guys is we have the set of living things, which consists of animals, plants. Okay, so those are the two major classifications that we have, plants and animals. Then under animals, we have human being, and then also have your forest or domestic mga pets or animals that we have. So we can actually class, you can see it here that there are 4 sets. Now, from this given set class, are there elements belonging to one or more set? Okay, are there sets class which belongs to one or more sets? Okay, for example class, if you want to take a look class, you need to examine all these objects here. These are all set of living things. So that's one set. Then inside your sets of living things, we have also the set of plants, the set of animals, and under the set of animals, we have here the set of human beings. So there is what we call class a set which belongs to another set. So we call that one as subset. So for example, the set class of human being is a subset of the set of all animals. And then the set of all animals is a subset of all, is a subset of the set of living things. Then another one, the plants, the set of plants is a subset of all, of the set of living things. Again, the set of plants class is a subset of all the set in the set of living things. So we could see here class that one set can belong to another set. So if one set class belongs to another set, we call that one as subset. Okay, so this should somehow give you an insight of what a subset is all about. Okay, so what do we mean by subset? Okay, mathematically speaking, class stated here that A subset is just a set of X such that a set X is a subset of set Y if and only if every element of X is an element of Y. So what do we mean by that? So if we have here class set Y, which contains elements 2, 4, 6, 8, and 10, and then we have here set X, which contains elements 2, 4, and 8. If I want to compare class, the elements of set X and set Y, we can check class that all elements class under set X, okay? Again, all elements in set X can be found in set Y. Do you agree? Are there elements 2, 4, and 8 in our set Y? Okay, yes, we have 2, 4, and 8. So all elements class of set X are found in set Y. Hence, we call class X is a subset of set Y. Okay, well, let me try to erase this one. Okay, to represent class, the notation for subset, so this is how we write subset. Okay, X is a subset of Y. Or this is also known class as X is a proper subset of Y. Now, by the way, this is the symbol for your subset. Then if we have this symbol with an underline, we call that one as proper subset. Okay? So let's talk first class about subset. So to represent this one, we could say that X, okay, let me erase all these writings. Okay, so we have, again, to show that X class is a subset of Y, we could read it this way. X is a subset of Y, okay? Whereas this one class, with this underline, this is referred to as proper subset. Again, let me type that in our chat box. We call that one as proper subset. But first, let's get to understand class about subset. So when can we say that a set is a subset of another set? We can say class that a set is a subset to another set if and only if all the elements of a set can be found in the other element and the other set. For example, set X class, set X here contains elements 2, 4, and 8. And then if you try to check class, the elements of set Y, it also contains elements 2, 4, and 8. And then since class, all elements of set X can be found in set Y, then we could say that X is a subset of Y. Okay, questions so far, class, about subset? Some more questions, class, about subset. Now, questions?
No, sir.
Okay, so if there are no questions, I have a question for you. I want you, class, to create a subset from set Y. Okay, I just want to show, to know, class, whether you have fully understand the concept of subset by creating a subset from set Y. Okay, I want you to type your answers in our chat box. Okay, I'm waiting, class, for your answers. I want you to form a subset from set Y. You can name your subsets the way you like, but make sure you are following, class, the guidelines in creating a set. It should start with a capital letter, with an equal sign, and a curly braces. Okay, we have set Z contains elements 2 and 4. That's correct. That's a subset of set Y. Okay, X, 6, 8, and 10. Class, when you try to create a set, make sure to separate each element with a comma. Okay, I haven't specified that one, but then you should note, class, that each element should be separated with a comma. Okay, okay, Shan, we can improve your answer by adding a comma. Okay, So again, class, each element class should be separated with a comma, okay? 2, 6, 8, 4, and 8, 2, 4, 6, and 8. Some more? 4, 6, 8, and 10. Okay, some more answers. Okay, how about class if I have this set? Can we say that this is a subset of set? Okay, if I have this set class, set n contains elements 2, 4, 6, 8, and 10. Can we say that set n is a subset of set y? And class, from our chat box, you can check there. Is set n a subset of y? Is this true or false? Class, I'm waiting for answer. One answer true, 9 answer false. Okay, some more answers. If you have heard that again, class, set n, and these elements 2, 4, 6, and 8. And then set y also contains elements 2, 4, 6, 8, and 10. Can we say that set n is a subset of y? Okay, so the answer here, class, is true. Okay, set n can also be a subset of set y, even though it contains the same set of elements. Okay, so pwede siya nga a set can contain the same set of elements. But then, okay, so I do hope, class, that by now you can now comprehend the idea of subset. It could be a part of your elements of a given set, or it could be all of the elements are present in a given set. Then we can call that one as subset. Okay, now let's go back to the idea, class, about proper subset. So from here, in this illustration, class, X is a proper subset of Y. Okay, let me erase these writings. And let me add another set here. Okay. Okay, for example, class, I'm going to try to add another set. Let me just edit this PowerPoint presentation and name it as set n. Okay. Earlier, we say, class, that X is a subset of Y, and this is true. At the same time, we say that N is also a subset of Y, and this is also true. How about this statement? When can we say, class, that a set is a proper subset? So this one, class, is again a symbol for subset, while this one is a symbol of proper subset. When can we say that a set is a proper subset to another set? Okay, if you try to examine, class, set X and set Y, set X contains elements 2, 4, and 8. Okay, these elements, class, are also found in set Y, 2, 4, and 8. But then take note, class, that set Y, again, class, set Y contains at least one element which is not in set X. Again, let me repeat that for you. Set Y contains at least one element not found in set X. With that given instance, class, since set Y contains at least one element not found in X, then we could say that X is a proper subset of Y. So that's the idea of proper subset. So mean to say, class, not all elements can be found in a given set. Okay? If you're going to say, again, class, X is a proper subset of Y, I mean to say not all elements of set Y can be found in set X. So set Y contains at least one element not in X. Now, I have a question. Can we say here that N is a proper subset of Y? Is this true or false? Okay, using the same example as presented, can we say that N is a proper subset of Y? Okay, many of you answered false. Can you give me the reason why you said so? Anybody? Who would like to tell me that why did you answer true or why did you answer false? Okay, anybody would like to do it orally? Okay, let me select for those who answered false. Okay. Okay, I want you to tell me why did you answer false? Bianca Joyce Padiscio. Why did you say it's false? Bianca? Bianca Jeloisa, are you there? Oh, nag-true siya. Why did you say it's true? Padiscio. Bianca, why did you say it's true? What's your idea? Okay, don't worry, class. You are free to express your idea. Why did you say it's true and why did you say it's false? Anybody? Anybody class would like to tell me why is it true or why is it false? I want you to try to define your answer. Anybody? Let's start with true. Okay, Bianca, Shan. Okay, we also have John Raymond Mascareñas, Yoren, Florante, Silox, Jerome, Christian. Okay, why do you say it's true? Anybody? How about us for those who say it's false? Why do you say so, that this is false? Anybody would like to try to answer? Anong true, anong false? Okay, the class is silent. Or, okay, we have here answer from Therese Allison. False because set N contains all elements in set Y. Okay, so again, let's go back to the idea of proper subset. When can we say that a set is a proper subset to another set? Okay. Okay, let me try to erase these writings. Okay. Again, class, from our previous example, a set can only be a proper subset considering set X and set Y in this example. Set X is a proper subset of set Y because set Y, okay, set Y contains at least one element not found in set X. And what are these elements? We have elements 6 and 10. So elements 6 and 10 class are not found in set X. Therefore, X here is a proper subset of Y. And then let's go back to my question. Can we say that N is a proper subset of Y? So N here contains elements 2, 4, 6, 8, and 10. Okay? At the same time, set Y also contains elements 2, 4, 6, 8, and 10. So all elements class, again, all elements in set Y can be found in set N. Hence, we can say that N is a proper subset of Y because again, all elements class can be found, all elements of set Y are found or can be found in set N. Hence, we cannot say that Y or N is a proper subset of Y, but we could say that N is just a subset of Y. Okay? Did you get class idea of subset and proper subset? Proper subset, a set contains at least one element not in the other set. But then, for example, if we're going to add class an element, okay? If we're going to add an element to set Y, which is, for example, we add here element 12, okay? Set Y now class contains elements 2, 4, 6, 8, 10, and 12. while set n contains elements 2, 4, 6, 8, and 10. Therefore, we could now say, or we can now safely say that set n is a proper subset of y. Because again, set y contains at least one element not in set n. And this makes a statement true. So did you now understand, class? Did you get the idea of subset and proper subset?
Yes, sir.
Okay.
Yes,
So
sir.
that is now clear about subset and proper subset. Again, this one is a symbol for proper subset, while this one is a symbol for subset. Okay, that's your about subset and proper subset. Okay, so now there's a next slide now. I didn't. Okay. Well, anyway, given our previous example, y and x, y has at least one element which is not an x, and we call that one as proper subset. Again, from here, oh sorry, murag nabaliktad ang symbol. Okay, sorry for that. The symbol, class, this is subset, while this one is proper subset. Okay, please be corrected. So again, this is a symbol for subset, while this one is symbol for proper subset. Okay, sorry for the corrections. Okay, so I do hope, class, na you follow with the symbols. This one is symbol for proper subset, while this earlier, this one that is a symbol for subset. Okay, this one element which is not in X. How about equal set or equal sets? When can we say, class, that two sets are equal? Okay, so when can we say, class, that two sets are equal? Again, from here, from this PowerPoint presentation, it states that two sets are equal if the two sets contains exactly the same set or the same elements. Exactly the same set, or it contains the same elements regardless of the arrangement. So for example, this one, we have our set X and set Y. Okay, set X contains elements 2, 4, 6, and 8, while your set Y contains elements 2, 8, 4, and 6. If you will try, class, to examine all of these elements, 2, 4, 6, and 8, both set X and set Y contains the same set of elements. Therefore, set X, class, is equal to set Y. Hence, we call them as equal sets. Okay? If two sets, class, are equal, then we could say that they are a subset to each other. Okay, class? If two sets are equal, then they are subset to each other. That is, X is a subset of Y, and Y is also a subset of X. But then, class, we could never say that X is a proper subset of Y, and we cannot also say that Y is a proper subset of X. This is wrong. Okay? Question so far, class. So again, class, equal sets. Two sets containing the same set of elements regardless of their arrangement. Any questions, class, or clarifications about equal sets? Class, questions? Sub 10 ang equal sets.
No, sir.
And then lastly, we'll be talking, class, about disjoint sets. So disjoint sets meaning to say the two sets it doesn't have a common element. So for example, X here is a set of all vowels in the English alphabet. And then set Y here is a set of all counting numbers from 1 to 5. So are there elements, class, common to set X and Y? So there are none. So no elements, class, are common to set X and set Y. Hence we call, class, set X and set Y here as disjoint sets. Again, disjoint sets, these are the sets which doesn't contain a common element. Okay? Questions, class, about disjoint sets? Other questions? Okay, so I do hope, class, it's clear when we talk about subsets, disjoint sets, and equal set. And then one last set, class, to consider is all about null set. Okay? Why do we call this set as null? Or why do we say that this is a null set? Or when can we say, class, that a set is a null set? Okay? A null set, class, is just an empty set. So mean to say, if it is an empty set, it doesn't contain any elements. So how is it written? It is written as, for example, this is just an empty set. But then again, this is, once you encounter this symbol, class, mean to say it is a null set. Then another symbol for null set is a 0 with a slash. Mean to say this is a null set. Now, can we say, class, for example, in this example, set X and set Y. Okay, sorry, no. Okay. Can we say that null set is a subset of X? Is this true or false?
False, sir.
True.
Okay, I want you to try answering this one. Try to answer, class, in our chat box. Try to say if it's true or false. Or can we say that null set is also a subset of set Y? That is still the same concept. Is it true or false? Okay. Now, one characteristic, class, of a null set or an empty set is that it is a subset to any set. So mean to say, this is an empty set is a subset of X. This is true, and the same is true with this statement, because a null set is always a subset to any set. Okay. Check it here. A null set is always a subset to any set, which makes the statement earlier to true. And also, the same time that we have to remember, class, that a null set is also a subset of itself. But to illustrate, to illustrate this statement, wherein a null set is a subset of itself, we'll say here that null set is a subset of itself. Or you can have this one, an empty set. A null set is a subset of a null set. So that's one important thing that we have to know, that a null set is always a subset to any set. At the same time, a null or empty set is always a subset of itself. Questions, class, or clarifications about equal set, subsets, proper subset, disjoint sets, and null sets? Other questions, class, or clarifications? Last questions?
None, sir.
Okay, so let me now stop sharing this PowerPoint presentation, and perhaps I should stop recording. Okay. And that ends for the lesson.